So let me, by show of hands, who here is still like less than 6 months, right, of experience with Go? Who here is still learning Go, picking up Go, writing Go for the, okay, quite a few hands. I see quite a few hands. Good, because this talk is going to be very valuable for you because this is the talk that I wish I had when I first started doing Go many, many years ago. So, on to the tactics. Before I do though, let's set the mood. Story time. I've been doing Go for about, I don't know, maybe 4 or 5 months at the time. And at my work, basically, we're asked to basically write some sort of a service that basically is going to hit some sort of a API endpoint to facilitate the test taking for students that basically go to school in sort of an underrepresented, underserved community, right? So for me, the stakes are high because these are the kinds of things I care about. Where I care about education, I care about poverty alleviation, and and technical education, and so that's why I work there. So I'm like, okay, great. This is actually going to deliver value. I'm going to see the impact, right, of my actual work. So we build a service, and we're supposed to integrate with this third party, right? Basically, as students sit down, they're taking their tests, and in the middle of the test, things start failing, right? And after a bit of an investigation, we find out that even though I wrote the test for the system, and I was very confident, right, of the test that I wrote. I was very confident in the work that I had done, right? What I failed to anticipate was basically that I was using the tool, I was using Go, right, in a way that, through no fault of Go, right, I was actually over-engineering something, right? I ended up basically hitting the API way too many times. I didn't factor in the fact that I might get throttled, right? The server started showing, our logs started showing a bunch of 429s, right? Basically, just our service was failing those students, right in the middle of their tests. I was crushed. Oh man, I was like, I tested this, we did all this work, right? And here we are, right? In the moment of truth where this thing needs to perform, right? It fails. All because I was so gung-ho about using Go. I was so excited about using the technology, especially Go routines, right? I basically went all out. I was like, okay, I'm gonna spin off a bunch of Go routines, and each of them are gonna talk to this API endpoint. I was firing off thousands of these things, right? And then basically hitting that server endpoint. The server was like, no mas, thank you very much. Started dropping all my traffic, and I was like, man, okay, clearly, right, Go is a very powerful tool, right? But there are things that we must be aware of, right, when we are implementing, when we are using it, right? And these are the things that even though there was a breadth of sort of material and content out there, and our best practices, and sort of content, blog posts, all these things, like I had consumed a ton of these things, but I didn't have sort of the real world experience of applying them, right? So what I call this talk the rush tactics, because really I had just a couple of months, right, from the time I was told, hey, you're going to be building the system, right? This is mission critical. This is the amount of time you have, right? So I imagine a lot of you find yourselves in these kind of situations where your boss or your team, your manager, whatever, you come to you and says, hey, you got to deliver this thing, right, in a very short amount of time. And you're like, oh, great, this is a great opportunity to use Go. I've been learning it. I'm ready. This is prime time. Let's go, right? So these are the things that I wish I knew. Very simple things, right? Once you see them, you'll be like, of course, right? But these are the things I wish I knew. So for those of you who are sort of going through a similar journey, hopefully these are useful to you. All right, tactic number 1. Some of you are already feeling where I'm coming from here. Implement only what you need. So for those of you who have been in my classes before, you know that I like to teach using code, live coding and whatnot. So this is not gonna be all slideware. I'm actually gonna switch over to real code. Oh, is this too dark? No, that's actually pretty good. Let's see what we got here. Let me switch over here. There we go. So, all right, so the first thing that I had to learn was basically to avoid pulling third-party interfaces into my code, Okay, so imagine you are tasked with integrating with, say, DynamoDB, right? AWS, thankfully, provides an SDK, right, that wraps all the functionality, right, for interacting with their service. And one of the first rookie mistakes I made was to actually, I went online and found the documentation for that SDK and found the documentation for the DynamoDB service in particular, and which might look something like this. Let's switch over, there we go. So if you do a little bit of search, you might come across DynamoDB or the AWS SDK for Go. And if you search long enough, you may come across the DynamoDB interface, right, in that package, right? So the interface, right, exposes a whole bunch of functionality, right, that, let me zoom in so you can see some of these things, right? It exposes a whole bunch of functionality that was like, oh, this is great. I can actually use this for my tests, right? That means, when I'm writing my test, I can actually, pass in something in my stubs and whatnot. I can actually, pass in something that implements this interface, right? So now the real client will also satisfy that interface, right? So I started using this interface. What little did I know is that when you're using interfaces in Go, the whatever implements that interface is an all or nothing shot, right? Either that concrete implementation implements all of the methods, or it doesn't satisfy the interface, right? So now here I was, I'm going through, I'm implementing these things. I'm like, I don't need any of this stuff. Like, why am I implementing all these things in my tests? And I realized, okay, well, I only need just one thing. I just need to put something in DynamoDB. Like, why implement all these things? So then I take a different approach. This is where I bring in, actually, let's go to, oh, and by the way, all of the material I'm covering right here is extracted from material I use to teach Go, especially for those that are sort of a new and intermediate level. So this information is going to be available after the conference. I will have a QR code that you can simply scan to get direct access to this wiki and all the code that I'm going to be showing today. Okay, so have no fear, all that stuff is going to be there and available for you. So if I go to the interfaces section here, hopefully my internet still works. There we go. The approach I took was to basically say, okay, the only thing I really need, right, let's zoom in, make it a little easier to see. The only thing I really need from the DynamoDB client, right, is the ability to actually put something in DynamoDB, right? Just one method, okay? So basically what I decided to do is like, okay, I don't want to bring in this third-party interface, this DynamoDB iFace client API. I don't want to bring the whole thing because that's going to force me to actually implement every single method in that interface. So I create my own locally defined interface. That's the DDB client that you see up there. And the only thing I need that client to actually do is give me the ability, right, to create a put item with context call. Where is this coming from? Well, in the DynamoDB package, put item with context, that is one of the methods in the interface, right? Put item with context. So that means because of Go's incredible power, right, and the implementation of the interfaces, where an implementer doesn't have to say that I implement X interface, I can simply have a client, right, that if I create my own interface that only specifies this one method, both my stubs, right, and the actual DynamoDB client will implement the interface. That single method interface. And that's the only thing I need. If we switch back to our tab here, this implementation, so basically the only thing I'm tasked with doing then is to basically implement whatever this is going to require. So now when I have my own custom DynamoDB saver, which is my own custom type in my own code, I can then say, hey, I'm expecting a client which implements my DDB client interface. And again, I only need a single method out of there. So what does that code actually look like? So my DynamoDB saver save method, right, uses the client internally, right here, right? So what does the implementation for this look like? Let's actually go to the code. And this is, I'm navigating here so that you will also have a reference for this. Hopefully this is legible from the back. Thumbs up if everything looks good. Great, awesome. So here we are. This is my DynamoDB, my DDB, my own locally defined interfaces. And I can't stress this enough. Rather than bringing in a third-party interface into your code, right, there's nothing that stops you from creating your own very small scoped interfaces for those things. I don't have to create a strong coupling with the AWS Go SDK by basically saying, hey, whatever my DynamoDB server needs as a client needs to implement the official DynamoDB interface client, right? I can separate those things. The only thing I need is my own client interface. Now, my own, and then again, the DynamoDB server actually uses that client internally. In my test then, you can actually see I create my own stub. I create my own test client. My own test client, the only thing it needs to satisfy the interface is the implementation for that put item with context. Okay. At this point, right, I have a complete implementation. I can actually write my unit test, right? I can be in a plane completely offline, right, and not have to actually talk to DynamoDB in my unit test, which I don't recommend, by the way, right? And now my implementation doesn't have a dependency on the DynamoDB API or SDK at all. So I can literally initialize my DynamoDB server, provide the client, which actually guarantees me that I have my put item with context. So now inside of my DynamoDB server, which receives the client, I can actually call put item with context. But guess what? What also implements this DDB client interface without actually having to explicitly say that it implements my own interface? I'm not expecting AWS to implement my interface, am I? Right? Because the actual DynamoDB client itself has a put item with context. So it implicitly satisfies my own locally defined interface. So you can actually see how decoupling those two things, you can actually bring them back together. So now when I initialize my own, like when I'm actually running this executable for real, right? If you've ever done any work with the AWS SDK for Go, this bit of code is going to look very familiar. I'm actually initializing an actual session with from the AWS package, creating an actual client that is going to talk to DynamoDB for real this time, right? And actually passing in this client to my DynamoDB server, right? Because again, the client, the real one that I'm passing in, implements that interface naturally. That single method interface. So I saved myself a whole lot of headache for testing, right? I decoupled myself from all of that extra code, right? If the API ever changes, that doesn't matter to me because the only thing I care about is my own locally defined interface. So let's summarize tactic number one. You avoid pulling third-party dependencies or interfaces into your code. You create your own locally defined interface, right, with the method of just the stuff you need. Your unit tests with stubs, right, they actually implement your own local interface, right? You don't have to worry about anything else. And the real client itself will naturally implement that interface for you as well. How does that sound? Good? Sweet. Oh, clap. Oh, I like it. I like it. I like it. All right. Tactic number two. So remember in my story, I'm talking about sort of in my logs, I start looking around, I start seeing those 429s. I'm like, oh man, this is heartbreaking, right? This is such an avoidable problem. So ever since that situation, right, what I've started doing is by default, I make any sort of remote interaction with any sort of remote service like resilient by default. If I'm writing a server, okay, and I expect clients to come talk to me, right, I don't want my server to fall down if all of a sudden those clients, right, start bombarding me with traffic, right? Ideally, there's some sort of gateway in front of my service that's gonna do some of that throttling for me, right? But like I don't know that for sure, right? And so what I've started doing is in my servers, I'll implement throttling, right? Because I can sort of control, right, how much traffic I want to receive and I want to handle, right? Maybe I have some other services that I'm talking to behind the scenes that I don't want to sort of proxy a bunch of traffic to them, right? I want to control that, so I'll start implementing throttling in my own servers, right? And we're going to see what that looks like in a second. In our servers, the way we need to sort of, the way we approach this, right, beyond the throttling, the way we sort of handle, especially clients that are sort of I like to call them flaky, right? So imagine like you're on your cell phone, you're going through the tunnel, you were talking to a service just now, and because you're going through a tunnel, right, cell reception can't penetrate, in certain area, and whatever requests you were literally making, it just drops. So now, if you're the developer, right, the engineer who's written a server on the other end of that, depending on your implementation, you may actually still be doing the work while the client no longer cares about that work. Here's what I mean. So I'm gonna pull up a HTTP resiliency. Let's talk about server, context, none. Again, I'm going through all of this sort of folder structure. All this code is tied to that wiki I showed you, and you have a QR code for all of that stuff at the end. So don't worry about having to remember all this stuff. All right, so here we are. This is sort of my initial naive implementation of a server, right? So it's basically, it's just a greeting server, right? Simplistic. So a client's gonna make a call, expect a greeting back, okay? I'm gonna show what happens when you don't factor in the fact that when a client makes a call and you don't sort of handle the inconsistency that can happen with client-server interactions, what happens? So let's pull up our terminal here. I'm actually gonna run this code. And this is in the server. All right, so this is our server. We're gonna run our greeting server. Okay, our greeting server is running, ready to accept connections. Okay, so now, at the bottom terminal, I'm calling that server. So this is the sort of the initial interaction. Everything's good, the client makes a connection, it's waiting for a response, right? Everything's good, there's no interference in the connection between your client and your server. The server handles the request, everything's good, right? You get back your response, hello Gopher. All right, I'm gonna clear the top. I'm gonna issue this request again. This time, before the server has a chance to return, I'm gonna cancel my request. So in the bottom, I've just Control-C, I've just sent a signal to my client, but guess what the server's still doing? It's still thinking, it's still processing, right? This was a hard lesson for me to learn as well. Because now, if you have clients that are asking for work, and maybe that work is intensive, maybe you're crunching a lot of data, maybe there's a lot of other backends you need to talk to, right, to actually get formulate a response and send back to the client, and all of a sudden that particular mobile device goes under a tunnel, connection is lost, and your server is still working. How do we fix that? Easy. We bring in context. So, how do we bring in context? And what is context? If you're new to Go, and let's bring this, put this away. If you're new to Go, you may see a lot of a Go code, right, with the package context, right, in the standard library, sort of everywhere. And you probably see, like a context variable sort of being passed everywhere, right? There's a reason for that. Because context allows for propagation of cancellations, right? Meaning that if a client makes a request to your server, in our case here, and the client decides, okay, I'm for whatever reason, I either cancel the request or I've been disconnected, networks are unreliable, right? We need to know that cancellation happened, okay? How do we know that? Well, in this case, this is the modified version of our initial handler. And the first thing we're doing here, before we do any work, right, on line 15, we're grabbing a context out of the request. So the Go standard library does you a solid by basically saying, hey, incoming requests, right, they're gonna have a context available on them by default. All you have to do is ask for it. Once you grab that context, you can then pass it around to any other backends, right, that you need to make aware, right, should a cancellation happen, right, or deadline is exceeded, whatever the case may be, right? So that cancellation needs to be able to propagate because otherwise you'll still be sitting there doing work. So now that I've got this context captured, right, I can then use this. Again, this is a very contrived example. The only thing I'm doing here, the only thing that's different here is I'm waiting, right, for the ability to read from a done channel. Right? Once I'm able to read from a done channel, that just means one of two things, right? It just means that the client either doesn't care about it anymore, or if there's a timeout that hasn't been exceeded, right? That context basically has stopped. It's ended, right? So with this implementation, what does our interaction now look like? let's cancel this one. And let's go into the request context. And let's just run this version of our program. So at the bottom here, right, I'm going to issue that request, same request again. Now it's working. I'm going to cancel the bottom. And guess what happens immediately with the top? Now, our server has been made aware that the client no longer cares about this connection, right? So now we can then immediately stop doing the work. And that cancellation, we can now propagate that to any other backends that we had to talk to in order to sort of formulate a request or response, right, back to our client, right? So if you're doing a lot of database calls, waiting on long-running jobs or processing some heavy, manipulation, whatever the case may be, right, you now have the ability to say, hey, stop doing that work, right? Let's put our resources to better use to the next client that is actually able to wait for our response. Okay. The next piece of this is to throttle aggressive clients. I mentioned this before. You don't want your server, right, going down because of there's a one-off, right? Maybe some engineer is trying out your API, and who knows, maybe they put their request in an infinite loop, right? Maybe they're brand new and still playing around. Maybe there's an errant process, some zombie process that just sits there and keeps, hammering your server, like I did, and I got throttled, and I got punished for it, right? So how do we write servers that are resilient, right? How do we then tell a client, hey, you're sending me way too many requests. Slow down, buddy, right? How do we do that? Well, simple enough. The standard library, or at least the experimental part of the standard library, has our back here as well. And you notice there's a common theme throughout all this. I'm always talking about the standard library and the experimental package of the standard library. Like, there's a reason for that. I come from an SRE background. I don't like to bring a lot of third-party packages into my world unnecessarily, because the moment you do, you're not responsible for whatever that package does, right? So, and that includes security, that includes any breakages, anything like that. So I'm very sort of timid when it comes to bringing in third-party packages, right? Could I bring in a third-party package to do some of the things I've been doing and I intend to keep showing you? Yes, but I'm showing you all these things. You can actually do these things all with the standard library. You don't need to go, right, get something special, right? At least with understanding that you can do it with the standard library. If you choose to go beyond, that's up to you, right, depending on your needs. But everything I'm showing you is with the standard library in mind. All right, so let's now find all right, let's look at the server. Okay, so this is how we implement our throttling mechanism. So the standard library, or rather the experimental packages in Golang.org, right, have a rate, right, package that you can actually bring into your world to help you accomplish this task, right? So the way the rate package works, let's go to the main function to actually see how you initialize this. You will basically specify a couple of values for your rate. You're going to specify the number of requests you're going to allow per second, right? And you're going to specify a burst, right? So meaning that if you specify a 3 requests per second limit and you specify a burst of 5, that means on one shot, right, in that 1 second, right, the client can send 3 requests, but because of the buffer, he can send an additional 5 requests, thereby giving you 8 requests for that 1 second. But after that second, that grace period is over, right? Now you force the client to abide by the 3 requests per second limit, okay? So that's what the limiter is looking for. It needs the request per second and it needs the burst. So once I have my limiter, right, I can now use that limiter, right, as a common pattern for implementing that limiter, right, is actually, because we're writing on an HTTP server here, is to actually use middleware. So that every request that comes in goes through that middleware that then you decide, okay, have you exceeded, right, the number of requests you're allowed, or like, is the request okay, right? Just like you'd use middleware for, authentication or authorization or any other, the common use cases for middleware, your rate limiter can actually follow the same exact pattern. And this is exactly what we're doing here with this limit middleware. It takes in the HTTP handler, we return an HTTP handler, just like any other piece of middleware, and inside of that middleware, we're actually using our limiter and saying, hey, is this request allowed? Right? Or not even is this request, is whatever it is that I'm asking for, is it allowed, right? If it's not allowed, that means I've exceeded not only my request per second, but my burst as well, okay? So what does that translate into, right? And obviously, if the request is not allowed, we can tell the client, hey, you're not allowed, right? We can send back that 429, right? that request, that response I love so much, right? Which has taught me so many lessons, right? We can actually send that back, right, to the client, be like, my turn now, to basically prevent our server from falling down because of too many requests. So what does that actually look like, right, when we actually run this? So let's find ourselves in the right folder here. Let me look at my time. Ooh, I am running out of time quick. All right, so here's what I'm gonna do. Okay, so I am going to go run my server here. And what I'm gonna do is, inside of here, I have a make file that basically the only thing it does is just issues, it ensures that I'm going to be able to see how well my throttling works by simply issuing like 6 requests in quick succession, right? So if everything goes well, I should see that 429 coming back from our server. And you can see, and here we go, let me close some things here so we can see, so let's talk about what happened at the bottom here. So I made that request, so 6 requests went through immediately, right? So the first one is okay, second one is okay, third one is okay, right? So I specified, right, in my code, I specified a default rate of 1 request per second with a burst of 3. So that means in theory, 4 requests should have gone through successfully, and anything beyond that, within that same second, should be throttled, okay? So after, and you can see after the first 4, right, the one allowed for the initial value, right, in the burst, right, those 4 requests, I start getting too many requests on every subsequent request, right? So the last 3, right, of my requests didn't, or the last, yeah, I think the last 2 or 3 didn't actually make it, right? So this is how you can actually build throttling into your code. Again, because of a time constraint, I'm going to speed through, or rather, I will point out the other pieces that I didn't have a chance to get through, but we'll at least show you where you can find more. So your client can also implement what's a backoff strategy. Again, so this is one of my favorite examples because a lot of times when what I should have done when talking to a remote server was to, in effect, know when the server is actually telling me, hey, back off, right? You're sending too many requests, you're exceeding, and usually there's documentation in those APIs that basically says, hey, like you're allowed X requests per second. So you as an engineer, you're supposed to take in that data and appropriately calibrate the amount of requests you're going to make, right, to that limitation, okay? So in my case here, I have a few requests that I'm trying to make, and I have one implementation which has a back off. And again, for the sake of time, I wish I could demonstrate what happens when you don't have the back off, and if in effect I do get throttled, just like we saw before. But this implementation with the back off, you'll notice that I'm again using the standard library, nothing fancy, right? I don't have jitter and all those extra bells and whistles that you get from third-party packages that actually handle some of this stuff. The only thing I do is I set up a quick back off schedule and basically say, okay, as I'm making continuous requests, if at some point I get throttled, I'm gonna basically start going through those times. I'm gonna start going through them and basically say, hey, like you just got throttled. Let's just wait for this amount of time and then try again. Okay, so basically we just have that in a loop here, right? And the only thing we're doing is whenever we get throttled, right? If you happen to get to 103, right? You basically say, okay, I'm gonna wait, right? I'm gonna do another iteration. I'm gonna wait for 2 seconds, and then for 4. And then for 8. So whatever that number, however amount of time you want to wait for each iteration, you can simply play around with those numbers. So again, you can do this all by yourself without having to bring in some third-party package. Okay? All right. So I'm going to move through the rest of this pretty quickly. So we've seen the back off. This is what we're just looking at. So bound your concurrency. So this one was a basically in combination with the number of requests I was making, right, with that server. This one bit me hard because this is where I was actually spinning off thousands of routines, hammering that server, and basically, you know, I ended up getting throttled. So the only thing I should have done was basically when you know ahead of time, right, that the number of requests you're about to make, the sync package's wait group type is your friend, right? If you know you need to make 1,000 requests, right, to a particular endpoint because you have 1,000 things you're trying to get a data back for, you can use a sync wait group. It's a perfect use case for that. When you don't know, right, when you don't know how many requests you are going to make, but you'd rather have a set number of workers, right, that are going to be picking up the job and doing work for you, right, worker pool pattern is an excellent implementation to adopt as well. And again, in the interest of time, all that code is in the repository, but I will keep moving and bring up some of the other points. The semaphore, right? Also a great pattern to use when you need batches of Go routines to be executed at once or not at all, right? Imagine you and your friends go to a restaurant, you need a table for 4, right? There might be sparse tables, right? With table with 2 people here, 1 person there, right? But you 3 and your friends, there's a party of 4. You need all 4 seats to be available in order to actually, you know, go in and eat, right? Semaphore is that concept, right? That allows you to implement that batch of Go routines at once. All right. The bonus tactic, right, to wrap up, is to make it observable. One of the things I didn't do, right, was to actually instrument my code to know when something was happening. Somebody had to tell me that, hey, some of the students are reporting issues, right? And it was hard to debug because it was some of the students having problems here, some weren't, right? That intermittent kind of problem where it's not a logic bug or whatnot. It's just intermittent kind of issue, right? That's a dead giveaway that you may have. Maybe you're talking to a resource that is being exhausted, right? So make your code, make that behavior observable. So learn OpenTelemetry. OpenTelemetry making another comeback, right? in this talk here, right? So I've been in this industry for quite a while, 25 years now. So I've never seen anything more plain in my career, right, from a professional development standpoint than in terms of what to learn next, right, as OpenTelemetry. The entire industry is moving in that direction. So if you write backend software, right, you're using Go, right, learn OpenTelemetry, you're not going to regret it, okay? Use traces and metrics. You notice I didn't say logs in here. Because as you start using traces and metrics, a funny thing happens. You start to rely less on logs, right? And if you're going to do logging, still do, best practices, structured logging and everything else, right? But if you have traces, right? If you have, you can tell what, for each span in your trace where most of your time is being spent, right? And if you have metrics, counters that are basically keeping track of how many times something happens, you have gauges that are going to tell you, you can bucket things, have histograms that tells you, okay, most of the time things are, in that 400 range or 600 range, whatever it is, right? If you have that data, you can make more informed decisions. And you can actually have alerts triggered, right? For those of us who carry a pager, right? You can actually have alerts trigger based on anomalies, right? In that data. So learn OpenTelemetry, rely on traces and metrics. Ooh. That's much better. Rely on traces and metrics, and rely less on logs. In the immortal words of Big Pun, I'm not a logger. I just trace a lot. But did I just age myself? And Big Pun never said that. This is just a play on words. In any case, a quick recap. Implement only what you need. Make remote interactions resilient by default, right? Don't assume some services are always going to be there, respond to you in unexpected ways. Bound your concurrency. And this is the QR code for that wiki and all of that source code that you saw that we didn't get a chance to get through everything. If you're the live training kind of person, I basically teach on O'Reilly on a regular basis. So find my next training, and you'll have a lot more time to actually practice some of these things that I'm preaching here, I guess. If you like the pre-recorded stuff, I can be found on LinkedIn Learning as well. And if you want to get in touch, either after, in the hallway track after the conference, or at any point in the future, this is my GitHub handle. Please don't hesitate to reach out to me. I'm a big fan of community building. Hopefully, you can see that I'm pretty friendly. So come talk to me. Don't hesitate. And any questions I can answer for you and guide you in the right direction. Especially if you're new to the community, I'd love to help you out. All right. Thank you so much.